Hello. So, Kenny, first one here, or first one in the chat, but nice to see you. Hope your classes are going well. What classes you taking this semester? I think you mentioned linear algebra, but I forget what the other ones were. Because I'll do my best to help with anything you have, but if anything, Kenny, I think I'd be calling on you to help my current students. I'm definitely a little bit rusty. Oh, he's been getting out of hand. Oh, I think Kenny's doing all right, but my evening's going pretty well. Nice to have you on, Psycho Slayer. Hope your evening's going well as well. It's not easy to say. Yeah, nice day off of work, but I want to keep to the Wednesday 8:30-ish schedule. Oh, wow, that's a nice lineup. Calculus 3, linear algebra, geology, and data structures. Very nice. So you're getting a lot of those core math classes out of the way. But I'm glad you were able to skip right to Calculus 3. Getting that 5 on the BC test. Very nice. So I guess, let's see, it's good. Oh, I'm glad your evening's going well. So see, we get some people with algebra to Calculus 2 level stuff. I'll start answering math questions. But Kenny, I think I'm inspired. I probably won't be able to do it by the time your college time is up, but I think down the line I want to relearn Calculus 3, maybe differential, linear algebra, like, the core math classes you take in college. I want to relearn those so that, for homework help, it'll extend to college kids as well. Don't have to take any math classes. Very nice. Yeah, this is, if we just talk life for a second. Yeah, I tell people, you don't have to go the math route, the STEM route to be successful. Some people just want to do their one math class and be finished. So there's nothing wrong with that. I have plenty of friends that just took their one math class and their jobs, they're very successful. They're doing quite all right. Oh no, Kenny, you put in a lot of work. I appreciate you giving me the shout out for you getting the 5, but getting a 5 is, it's my job to try to make the content easy, but I mean, you showed up every day, you were focused, you did all the work, like you paid your dues. You put in there's no easy way to get your way to a 5. You definitely put in the time, so but I appreciate you giving me the shout out. But I mean, when I talk to, the future classes and my current class, I give the strong students of the past the shout out they deserve and say, like, because you all give me the confidence too that I could lead, a group to getting 5s on the test. And then that inspires the next group as well. So last year was a special year because, we had just kind of got back to school out of the pandemic. And it was nice to be back in front of a group of students again. And the results from the BC test that year was definitely stronger than the year before because that whole year was remote. So it was like really special to be back with a class in front of me, and proud that so many of you did well. So very nice. CS major, finite math, take some extra math classes during the summer or winter. Oh, very nice. Yes, CS is another great major. It'll definitely get you paid. So in 2022, that's a very popular, or not necessarily popular because it's hard being a CS major, but I mean it's a in demand major for companies. Like they want CS majors. So that's great that you have a bit of programming. That these days, if you major in pure math, then unless you're getting into teaching, you're almost like certainly going to be expected to have a little bit of programming, on your resume. So, being able to speak that language is great. You looking to do? I'm not too well versed in computer science, but you looking to do programming or like web development? Because I know it's a really broad topic. So, Yeah, I guess. Oh, Tommy, hello. Nice to have you. Have you joining on. Yeah, and right now I'm just chatting with people, but anyone who has a math question, I could definitely, get some math. I think I have a whole. I think I have a whole practice set of questions on limits and derivatives, just in case people don't have something specific. Oh, okay. So there are a lot of CS graduates. All right. I mean, I guess that's good for the students, because I know computer science does have a reputation of being like a challenging major. Um, oh, game development. See, that's a lot of fun. I feel like that's a lot of like high school. AP Classroom is based on completion. Yeah, just because what we're gonna do, I can't go over specific AP Classroom questions because those are like copyright protected. But what I'll say is like during actual class time, I could go over like the toughest ones that the class missed. So that's kind of like the inspiration of that. The AP Classroom is stuff that I could go over in the classroom. Packet questions, stuff like that. I could go with, but College Board is like very strict about their content. So, yeah, Kenny, I think majoring in math and yeah, game programming is a lot of fun. And I know some of those games, like which one was it? Like Red Dead Redemption and like The Witcher. There's some games where there's like so many programmers working for it, or like on the project. So it's just like a massive, massive, project, and they just have so many programmers going. But I don't want a desk job for the rest of my life, though. Actually, get an administrative position. All right, so this is like once I get like a specific math question, I'll switch back to that. Let me change gears here to fireside. All right, so now because I'm just like mainly answering questions, so having the whiteboard in the background, I guess I'll start with the chat. Oh, Red Dead Redemption 2. Yeah, I beat that game, and it's so much fun. I mean, I know it's a violent game, but I do love those games. And I remember one of my former students, who I won't name, but she was a great student, so I'm not saying anything bad here. She did very well on test, but I remember her saying like that she beat Red Dead Redemption 2 twice in a pretty short amount of time too. And then, let's say she had missed a homework assignment or two, and she tried telling me, "Oh, I just don't have a lot of time and blah blah blah." And I'm thinking like I beat Red Dead Redemption 2 and that took me forever. I'm like, "And you beat it twice." So, you telling me you don't have time to do homework. I'm like, I think maybe play a little less video games, but the story was so good. It was a lot of fun. It was basically, it felt, because it's Rockstar, so it had that same type of feel as like Grand Theft Auto in terms of like the gameplay itself, like in navigating. But it was done very well. It was a great game. Red Dead Redemption 1. All right. Yeah, no, I'll definitely down the line check it out. Maybe they'll release it as sometimes they release the old games and you can play it on the new consoles. So definitely look into that. Yeah, I don't know if I played the first one. I played I don't know if it was the original, but on Xbox, the original from 2003, I played, I think it was like Red Dead Revolver or something. So I played like the original Red Dead game for Xbox. So like whichever one came out first. I think it was in early 2000. Like that's the game I played. So yeah. But yeah, it's a fun game though for sure. Definitely like that game. I'm a math channel, but it's turning into video games. But I think video games is something that math people could definitely agree on and enjoy. Oh, okay, backwards compatible. Very cool. Yeah, so definitely a fun game. I'm trying to think if there was. Oh, I remember going to a wedding way back. Way back. It was 2019 in April, and I met, me and my wife were talking to this couple that was like friends of a friend, and one of the guys, I remember he worked for, I believe it was Fortnite. He was a game developer for Fortnite, but he definitely made a lot of money. He didn't say exactly out loud how much he made, but you could tell, like, even like at the time, he was in his probably late 20s, but he was doing really well for himself. Fair share of Nintendo. Yeah, no, Nintendo. Some of my earliest memories were playing regular Nintendo. So then N64, and then it just kept evolving from there. You were here and now you're gone. Oh, very nice, Jare. Yeah, I'm gonna start doing some math questions. I was waiting for someone to say, like, help me with limits or help me with derivatives. So if there's any specific topic for the math people that you want to see, let me switch to whiteboard so people are like, why is there a fireplace? So now back to the whiteboard. Yeah, I'm slowly getting better with OBS. That's the software I'm using. Yeah, like the small, I know, like CD Projekt Red for like The Witcher, because Witcher 3, that was a game my students told me to buy. I think it was like 2017 or maybe 2018, and they told me to get The Witcher, and I did. And I liked it. It was definitely a fun game. It was kind of like Skyrim, but just, I guess, newer in a lot of ways. All right, let me see. Maybe I'll just go through some limit questions until people say something specific. Now I gotta see, there's the fast way to scroll. All right, so this is from the AP Calculus Problems book, which some teacher with a PhD in math made for their AP Calc students. So it's a pretty nice resource. Let me just make sure here this is looking nice, and it is. Okay. Crucial notation for Calculus BC. Yeah, so Jada, what I'll do is, as I'm going through questions, I could talk about notation. That's really important. If there's any specific one you want to see, because as of now, we're up to derivatives, so it's really just limits and derivative notation that we'd have to master. Okay, Cyberpunk 2070. All right, so I'll keep that in mind, because CD Projekt Red, I'm a fan. All right, so I'll just go through some practice questions here. Which of the following is continuous at x equals 0? So multiple choice practice. And for these questions, it's all thought process. So some of these you could just visualize. So like Roman numeral 1, absolute value x, looks like this. So when I see that, I think, all right, I could draw that in one motion. So that means that Roman numeral 1, checks out. Because the third grade definition is that we can draw the graph in one motion. Okay, so this is big. So 1 is automatically true, which I already marked it off, so I'll get rid of that stray mark. Now, this one comes into mind. E to the x looks like this. I could draw that in one motion. It's an exponential function. So 1 and 2 work. So these choices are out. And honestly, now that narrows it down to just choice C. But now that's going to tell us that Roman numeral 3 should not work. So here, in order for a function to be continuous at x equals 0, so at Jada, what's the crucial notation? In third grade language, we say we could draw the graph in one motion. But in calculus language, we would say if the limit as x approaches 0 of f of x equals f of 0, this would tell us that f of x, so this means that f is continuous at x equals 0. So in terms of notation, writing your continuity explanations should look like this if you're saying at a specific value like 0. So the easiest way to show that 3 doesn't work is to just plug in 0. And if you looked at f of 0, that would be natural log of e to the 0 minus 1. And this is going to give you natural log of 1 minus 1, which is undefined. Okay, so if f of 0 is undefined, then this is not going to be possible, so f is not continuous. That's why it's just 1 and 2. All right, that's something to be mindful of. All right, and anyone just joining, thanks for swinging by. Just know that if you have a specific question other than, you know, limits or derivatives, because I know I have a lot of calculus people here, but anyone from algebra, geometry, trigonometry, precalculus, if you have a topic you want me to cover, just type it in the chat. Over time, I'm going to leave instructions to email me the questions ahead of time. That way I have time to work it out so my explanations are more crisp. But, you know, any topics you want me to cover, just let me know. All right, so 2 is more algebra. So this is just algebra. But, you know, I still like this limits practice test. So if we look at this here, we take a function and we reflect it across the x-axis. So we're reflecting across the x-axis, then we're shifting it up 2 units. So if you did forget, I would think of something like x squared. Okay, so x squared as a graph looks like this. But now how would you reflect this over the x-axis? Just put a minus in front. See, and that would flip it upside down like this. And then if I want to shift it up 2, let me just extend this thought bubble. So if I want to shift it up 2, then I would do negative x squared now plus 2, and it's going to look something like this. Okay, so which of the following describes that transformation? That's going to be choice E, that we put the minus in front, then we attach the plus 2. Okay, this is only a reflection over the x. This is only a shift up 2. This one is a little bit different. It shifts the graph to the left 2, then flips it. And this one shifts the graph to the right 2 and then flips it over the x-axis. So those are out, and that's definitely choice E. All right. Oh, Xiaolong, hello. Nice to have you join us. I don't know if I said hello yet. I am a little bit sleep deprived, so some of my short-term memory, you know, my short-term memory is a little bit compromised, but my math is hopefully intact, which I think my math will be okay. All right, which of the following functions is not continuous for all real numbers x? So for something like this, before I look at any answer choices, and I'm being honest, I'm not looking at the answer choices, I'm focusing here, is I'm looking for, once again, there's a few things that could fail. If we just look at the definition of continuity at x equals c, what I look for is 3 things are possible. So either the limit does not exist, f of x is undefined, and then the most annoying case is that, like, basically this is not true. All right, so these are the 3 possibilities I'm looking for, and it's for all real numbers x. Okay, so we need to go from negative infinity to infinity. So one way of determining if a function is continuous is that if you could draw it in one motion. So x to the 1/3 power, this function, if you sketch it, I think of x to the 3rd looks like this. So x to the 1/3 looks kind of like this. So this is a continuous function. Otherwise, I just think, is our function undefined anywhere? And we would say no, because we could take, this is the same thing as the cube root of x. I could take the cube root of 0, and I could take the cube root of negatives. So this is continuous for all values x, so this is out. Now, we look at choice B, and right away this one's looking good, because what's jumping out at me for choice B is I want to analyze f of -1. That would give us 2 over 0 to the 4th, and this is undefined. So because our function is undefined at x equals -1, that means our function is not continuous at -1. So f is not continuous, and I'll abbreviate, is not continuous at, I don't know why I want to write is, f is not continuous at x equals -1. So choice B is it. Now, I'll go through the others, but why is choice C okay? Choice C is absolute value of x plus 1, which shifts the v shape to the left one. That's definitely continuous. 1 plus e to the x. Some people might choose this because they'll think, oh, wait a minute. If I have the square root of a negative, that's bad. But just know e to the x on its own is always positive. Okay, and this idea shows up a lot. E to the x is always positive. So 1 plus a positive is always positive, and if we're taking the square root of a positive, that's not a problem. So that's why this is out. Now, someone who's not careful might say, oh, wait a minute, I have a fraction, and when the denominator is 0, my function is undefined, which would mean my function is not continuous. However, x squared plus 9 is also greater than 0 for all x. Okay, and we could say all x that are real numbers. All right, if you just think about choice E, x squared plus 9 looks like this. All right, it's a parabola shifted up 9. So our denominator is something that's always positive, so it doesn't matter what we plug in for x. We're not going to have any problems. So definitely choice B. Hi, I have an 8th grade math test in 30 minutes. Good luck. I hope your test goes well. I'm curious which part of the world you're in if you have a math test, because right now it's like almost 9 o'clock on the East Coast. But good luck on your test. So let's see, any other questions? Oh, just good luck in the chat. All right, so moving on. So we'll call this like mastering limits. All right, this one is so easy that it's difficult. This limit as x approaches 1 of ln x over x. Now, multiple choice, so back at what Jada had said before, going over notation. For multiple choice, your notation could be kind of sloppy. But when we're doing limits, the first thing that you should try is to plug in. So here, my first instinct is just to plug in x equals 1. So I'd have natural log of 1 over 1. But then we have to know that natural log of 1 is equal to 0. And 0 divided by 1 is equal to 0. So 4 is choice B. All right, now if you don't know why natural log of 1 equals 0, just say like y equals natural log of 1 like this. And what we're really saying is like e, because the base of natural log is e, to the y power equals 1. And then you're just asking yourself, what power would make this term equal 1? Y has to equal 0. Okay, so when I'm doing these in my head, maybe a better way of explaining it, because part of the skills you need for AP Calc is how to do not just limits, but how to evaluate natural log and trig functions without a calculator. So this, I just say e to the blank equals 1. And then the blank has to be 0. Okay, so that's where choice B is coming from. All right, so we are moving on here, and we're at about the 25-minute mark. All right, so we're making nice progress here. So for 5, this one, there's a few ways we could do this, but my first instinct is that when we have 1 over 0 plus 1 over 0, it's tempting to like, I don't know, you might just want to jump and say that this is going to be like a does not exist scenario, but this needs to be investigated. So what we have is we're going to combine these terms here. So this I would just multiply by x over x. And this is going to be the limit as x approaches 0. And we're going to have x plus 1 over x squared. So now at this step, what we have is, let's just see. So thinking out loud with this one. So if we plug in 0, all right, well now at this step, this is a little bit abstract, this type of limit. This is all, I call these, this is a number sense limit. So number sense limit, okay? So for this kind of limit, what we have is, I think of when you have something like 5 divided by 0.1 0, 0, 0, and let's say it's just a bunch of zeros and a 1. This heads towards positive infinity because it's a positive divided by a tiny decimal. Let's just say there's like infinite, approaching infinity zeros. And then a 1, this goes to positive infinity. But if I had 5, let's say, I could say it like this, 5 divided by negative 0.00, and then a bunch of zeros. So this is also infinite. And a 1, this goes to negative infinity. So this is kind of what's going through my head here, that when we plug in 0, what I'm imagining is that I'm plugging in something like x equals 0 point, and then if I just had a whole bunch of zeros and a 1, so like infinite zeros and a 1. Well, on top, I would just have 1 because I have 0 plus 1. But on bottom, I would have something like this. And it's being squared. So what this means is that if we investigated the limit on the right side, like when I think of like 0 plus, what I think of, so this is all my thought process. 0 plus, I think of 0.000, a whole bunch of zeros and a 1. And then the rest of my thought process, when I have 0 minus, this is negative 0.00, a whole bunch of zeros and a 1. All right, but when I have something squared, that tells me it doesn't matter if it's negative or positive in the parentheses, that it's going to go positive. But now 1 divided by a tiny, tiny decimal goes to infinity. All right, so that's how I know this one's going to be choice E. But this is probably one of the trickier kind of limits to find. This is a number sense limit. Because some people might say, wait a minute, 1 over 0, isn't that indeterminate? But no, the indeterminate form to look out for, indeterminate, we would get something like 0 over 0. So this is indeterminate. Indeterminate. I hope that's how you spell it. I'm pretty sure that is. Okay, 5 is a good one, especially without a calculator. All right, now this, all right. So these kind of limits, when your leading terms have matching powers, then the limit is just equal to the ratio of the coefficients. And this is because we have limits at infinity. Okay, so this is for limits at infinity. So here, this is going to be equal to just 1 over 2. Okay, 6 is going to be choice B. All right, this is just going to be 1 over 2. Now, yeah, for that one, just know if you had something like this, if I had the limit as x approaches infinity, let's say of like x squared plus 1 over x to the third minus x, there's a helpful little theorem that says you only have to consider the leading terms when you're doing limits at plus or minus infinity. So that means I could rewrite this as the limit as x goes to infinity of just x squared over x to the third. I could ignore that plus 1 and that minus x. And this would give you the limit as x goes to infinity of 1 over x. And now 1 divided by a giant number goes to 0. All right, but otherwise what I tell myself is that if the denominator has the higher power of x and we're going to infinity, then the whole limit goes to 0. If the numerator has the higher power of x, so, if we have something like this, let's say, and let's say it's like, I'll even put a minus in here, like minus x to the fifth plus 7x squared over, and it doesn't matter how many more terms you have on bottom, like, let's say plus 3, something like this. I only have to consider my leading terms. So this and this, so this would be the limit as x goes to infinity of minus x to the 5 over x to the 4, and this is going to be the limit as x goes to infinity of, and this simplifies to just minus x. So now minus x, if I plug in infinity, or technically I can't plug in infinity, but I could say that this limit is heading towards minus infinity because that coefficient will change the direction here. A 2-column proof. Yes. Yeah. And I'll also answer the relationship between the critical points of a function and its domain. All right. So I'll answer the calculus question, and then Silvis family, I will pull up a 2-column proof to go through, and I'll kind of explain how I conquer those. Now, so I'll just quickly do the, let me just see if I could just add a page immediately after. All right, so let's see. Oh, cool. All right, so this is from, what's it called? So at Jada's question first, and then I'm going to switch to geometry. The relationship between critical points of a function and its domain. Well, just know the critical points, when I think of some function here, and maybe I shouldn't have used legal paper, but whatever, it's different. And let me zoom in here. So if I have a function like this, let's say I have a sharp turn, smooth turn, something like this, and I call this f of x. Critical points, so Jada, I'm hoping this is going to answer your question, but critical points can only exist, I don't know why this is writing a little funky, could only exist at values of x in the domain of f of x. Okay, so that's a essential requirement here, that it has to be part of the function. So at first hand, we could be like, all right, critical points happen at sharp turns, or they happen where the slope is equal to 0. So you see, like identifying critical points, I'll call this like critical point 1, critical point 2, and critical point 3. Notice it's part of the domain of f of x. Like you could spot it on the graph. So where the domain gets to be tricky is if you have something like f of x equals, let me think of one that's going to work. Let's say you had square root x. So square root x, the domain is x greater than or equal to 0. But if we look here, see how the graph looks like this. So if someone were to ask, like, is x equals -5 a critical point? Right away, I know this is a no. Is x equals -5 a critical point? And I would say no right away, because the domain is x greater than or equal to 0. So when we talk about something being a critical point, it has to be in the domain of the function. Now, one function in particular, now that I think of it, that's a great example of this, is something like, I'll make it g of x equals 1 over x. The domain is x cannot be 0, because that would be division by 0. But if I took the derivative, see how I'd get -1 over x squared. And a critical point occurs when, in two cases, either where f prime of x equals 0, or where f prime of x is undefined. However, that value of x has to be in the domain of the original function. I'm sorry, and I used f prime. I switched over to g. So let me just switch that to g so that it matches. Okay, so g prime, g prime. Now, for something like this. Oh, okay. Oh, you're in North Dakota. Very nice. And they teach wonky and weird from when I lived in Washington, D.C., because I did geometry in 8th grade also. Very nice. That's pretty advanced. If you're doing geometry in 8th grade, good for you. You're off to a strong start. So when we look at this graph, Jada, and then we'll switch to geometry. What we're looking at here is that if we aren't careful and we look at this derivative, we would say, oh, wait a minute, g prime of x is undefined at x equals 0. Because you see how 0 makes this freak out. But notice there is no function at x equals 0. You see how it's just a vertical asymptote, which is basically what the graph is approaching on the left and right side. So someone who's not careful might follow the definition and say, oh, wait a minute, 0 is a critical point because G prime is not defined at 0. However, we already said in the beginning the domain is all x except 0. So that's why we wouldn't include it. Whereas, if you had, let me erase this. The classic one is the bird function. Okay, if we had, let's say, h of x equals x to the 2/3, that looks like this, right? The bird function, because I don't know, it looks like a bird if you're a bad artist like me. Then this domain is all real numbers, because this is the same thing as the cube root of x squared. And you could plug in any x you want to that. But h prime of x is 2/3 x to the negative third. And this is the same thing as 2/3 cube root of x. So you see how h prime of 0 is undefined. But in this case, we could say this implies x equals 0 is a critical point. All right, just abbreviating. So in this case, 0 does count as a critical point because it's part of the graph. It's in the domain of the original function. All right. So does that answer it a little bit, Jada? Does that make more sense? I'm hoping it does. Sorry about the knuckle crack. I know we have a nice microphone here, so you all heard that. So now I got to go rummaging for a, what was it? The triangle proof question. All right, so let me go finding one. I'm going to grab one from so at Silva's family, I'm going to grab one from a geometry regents. So kind of like the worst kind that we deal with in, in our regions. Now, because this is going to take a little bit to go through, what I'm going to do here is I'm going to show you, let me just see here. I'm going to go to kind of just do it like one that's solved out. And then we could talk about strategy and common mistakes that I've seen students make on these questions here. So let's see. This one. Oh, wait a minute. Is this 6 point? Because I want to get one that's like kind of complicated. Let's just see. Oh, this one's not bad, actually. Let me go back to get one that's like a little bit worse. Okay, maybe this year, 2019, might have been better. I think I have a video on it too. Oh yeah, this one was pretty bad, 35. Okay. So now I'll take you through the thought process for some of these. Now, what I could talk about is also kind of like why I think students struggle with triangle proofs. It's definitely one of the more traumatic topics that you'll learn. So let me just see here. Let me do this. Zoom in a little bit. And I will snap a shot of this. I'm hoping we could read this. Let me just stretch this out. All right. So something kind of like this. All right. So let me just check out how this looks in the... All right, I think this is pretty good. Like we could all see this. All right. Now, or you could find a question too. If you tell me like, give me a link or something to it. So I kind of have to gauge also what level you're at. Now, what's some tips I could give? So tips is to label the diagram. So this student wrote a 6 out of 6 response without labeling. So, I mean, some people, they could just kind of go through this and they're fine with it. But labeling the diagram is big. And also, come up with the strategy first. Okay, or we could even say come up with a game plan. All right. So, hold on, let me find a question. So it's up to you, Silvis. If you see this one here, if this is something that you think is let me see. So one was in exercise 11 and 12. Describe and correct the error in finding the angle measure. The question is m angles to BOC equals. If you have, I'll write the email for this. If you have like the actual question, I'll say email it here. All right. So if you email the specific question here, like with like in its entirety, then I could take a look at it and I could like better help you with it. Because if it's about, where were we? 2-column triangle proofs. This would be like kind of like the worst, one of the worst kinds I think you could encounter. It has, I think, 9 steps. Yeah, 9 steps. So I'll keep my eyes peeled on my email. But I would say, yeah, if you could send me the question as like a screenshot in the email, then I will look at that. Otherwise, I'll talk about this one here as a reference. And we could use this to hopefully clear up some stuff. All right, because triangle proofs, I'm not going to say they're all the same because there are some that are easier than others. This one is like particularly awful. So let me just see. I'll check the email once more. Let's see. All right, so I'm going to go through this one. And when I do a triangle proof, especially anyone from New York would know that question 35 or 36 of their geometry regents is usually the triangle proof. And it's like the worst question on the test. But my mindset going in is either proving line segments congruent, so I'll abbreviate line segments, angles congruent, or in this case, proving with similarity. Okay, so this is a situation here where we're going to prove with similarity, and what gives it away is the proof statement is they want us to prove that TA, that's this piece over here, times HA, so I'm highlighting this in blue, that product is equal to HE times TH. Okay, so I'm just kind of labeling this here. And now what's jumping out at me right away is if I recolor code this, I mean, I could just recolor code this, is I see like 2 sides were selected in triangle HEA, and then 2 sides were selected in this triangle here, triangle HTA. All right, now what's a little bit tricky here is that the orientation of these triangles is a little bit off. So when we're going through a proof like this, let me just check one more time. All right, so the email, yeah, I'm going to stick with this question for now, is that I'm looking at a 6-point response. All right, so the first order of business, this gets you no points when you just state the givens. Okay, like that, they don't show mercy. This doesn't get you any of the 6 points. But what I do before I do any of this stuff, so like I'm going to pretend I don't see any of this right now, is my thinking is to prove that these 2 triangles are similar. And if these triangles are similar, what that allows us to say is we could say something like, let's say HE, this side, this shorter side HE over the long side HA is equal to, and then in purple, the short side is TA over the longer side is TH. So I'm thinking strategy-wise, I want to prove these triangles are similar, and that's going to allow me to set up a proportion between their sides. And then notice all you're doing from here is just cross multiplying. And this is called the product of the means is equal to the product of the extremes. Okay, so that's the fancy geometry lingo for cross multiplying your ratios that are in proportion. So I'm thinking here, before we write anything, that we have to somehow prove these triangles are similar, then we could set up a proportion, and then we could cross multiply and actually complete this proof. So that's where my head is. Now we start reading. So what they told us here, if you think about all the givens, HE, these are the tips. So I'm not even going to look at this yet. Label the diagram. HM is congruent to AT. So let's change colors here. We'll go green. So HM is congruent to AT. So I'm looking at this and thinking, all right, maybe this is a parallelogram. All right, that's where my head is going, that this is a parallelogram. It looks like a parallelogram, but my head is already going there. HT is congruent to AM. All right, so now it is a parallelogram because both pairs of opposite sides are congruent. So at some point I'm thinking, all right, this is a parallelogram, that's going to come into play here. Next, they tell us after the congruence that HE is perpendicular to MEA. So now we have that this is a right angle. So because we know this is a right angle, we're one step closer to proving that these triangles are similar. And we're also told that HA is perpendicular to AT. All right, so far so good. We have that these angles are 90 degrees. But now, how are we going to prove that they share one more pair of congruent angles? Because to prove similarity, you need angle-angle similarity. All right, so this is all strategy. Before we look at any of this stuff, my tips are to label the diagram, come up with a game plan. All right, I don't start writing anything until I know exactly how I'm going to prove this. All right, but so far I'm thinking, prove that this is a parallelogram. We know these are 90-degree angles here. And now, how do we use the fact that this is a parallelogram to talk about another pair of congruent angles? And now it's jumping out at me. Okay, so the last detail is alternate interior angles. Because these lines are parallel, because this is a parallelogram, these are parallel lines. See how we have alternate interior angles here? So that means this angle here, angle THA, is congruent to this angle. So now I could say these two triangles, the one in blue, so let's just highlight that. So this one here in blue, this triangle in blue is similar to this one in purple because they have two pairs of congruent angles. So now the rest of it is just getting everything down on paper. All right, so once again, at Silvis family and anyone else here for geometry, the main idea with proofs is understanding why this is true by labeling the diagram and coming up with a strategy or game plan. All right, because now it's just putting it all on paper. So HEA and TAH are right angles, and that's, because perpendicular lines form right angles. HEA is congruent to TAH because all right angles are congruent. Now, a common mistake is that people forget this line. So if you forget this, that's -1. Some people just say, oh, these angles are congruent because they're both right angles. You have to first mention that they are right angles. Notice they didn't tell us that those angles were right angles. They told us the lines were perpendicular, so you have to first define them as right angles before you could say they're congruent. All right, but once you say this, you see this establishes a pair of angles. Now, MATH is a parallelogram. Two pairs of opposite sides are congruent, so the quadrilateral is a parallelogram. And you could do a lot of abbreviations with these two-column proofs. I think most states would allow you to abbreviate because there's so much to write. But now, here's another one people might skip. This is also, if you forget this is another -1. So some people might just say, oh, those angles are equal because they're alternate interior angles. So the only way you know for sure that you have alternate interior angles is when the lines involved are parallel. So this statement is very, very, very important. Okay, so once you establish, after you define MATH as a parallelogram, once you establish this, then you could use alternate interior angles. So that's what they say next. Angle THA is congruent to angle EAH because alternate interior angles of parallel lines and a transversal are congruent. Now that we have two statements of congruence, see angle, angle, then we could say the triangles are similar by angle-angle similarity. And then remember the proportion we talked about? They set it up a little different. Okay, they said HA over TH. But either way, this is going to get you to the same answer. All right, this is okay, or we could say it the way we did. HE over HA is equal to TA over and then TH. All right, this is also okay. So then from here, the reasoning is that corresponding sides of similar triangles are in proportion. And then we're essentially just cross multiplying here. And then this is the phrase to remember. The product of the means is equal to the product of the extremes. Okay, so that's one of the last pieces that you do need. All right, so let me just check one more time for the email. But all right, so that'll do it on that one. All right, other questions here? Probably got time for like one or two more. Today I got to stick to the 1 hour time limit. So just have a few things to do before going to sleep. So other questions? Could be algebra, geometry, trig, calculus. So 56 views. All right, nice. Considering it's a day off from school, anyone celebrating Yom Kippur, happy Yom Kippur. But yeah, on a day off, I didn't anticipate getting a ton of people. I think people, if they get a day off, they're going to want to enjoy their day off. All right. Good question. So geometry. CPCTC stands for corresponding parts. This is annoying to write. Corresponding parts of congruent triangles are congruent. Okay. Please don't write this. Constipated people can't take craps. All right. Don't do that one. All right. Go with this one. All right. That's how I get my students to remember how to write it, though. CPCTC. Yeah, it's just a convenient abbreviation because no one wants to write this every single time. That takes... Oh, wait, I'm blocking. No one wants to write that every single time. No, it takes way too long. So... Yeah, I forgot about this overlay business. It takes a little bit getting used to writing in front of a green screen. All right. Yeah, that's... I always... So... Yeah, I always look forward to this time of the year. I'm glad you appreciate that when I get to use that joke. I think of my actual lesson at school, I have, what's that one? The one that makes you go. It's kind of like X-Lax, Miralax, I think. Yeah, I have like a picture of a bottle of Miralax when I show CPCTC. And the kids are like, why do you have Miralax there? And then I get to break it down. This job, you have to make it interesting somehow. And you teach the same thing every single year. It kind of feels like you're like stuck in the same movie. So, you know, the corny jokes really do keep it fresh. So, all right, other questions. I'm trying to eye the chat at the same time. And do we have other questions? Oh, I have to put my animations on here in case people forgot. I'm still new to this, like, self-advertising. Like, check this cool thing out, the subscribe. For anyone who's not subscribed, I'll just leave that on for the rest. It just looks cool. There was a few to choose from. Yeah, to advertise for them. Canva, I actually went with Canva Pro for a year because I think it makes a difference if the thumbnails are nice. I mean, unless you're like, I don't know, it'd be an interesting experiment. Like, would Mr. Beast have gotten as big as he got if his thumbnails were bad? Like, I don't know, but I imagine him building a Willy Wonka chocolate factory would still be a great video, even if his thumbnail was garbage. But I think it shows that you care if you take the time to, you know, throw those things in. Yeah, any type of integral you'd like to see? Can you go over some integrals? Yeah, what kind of integral are you looking to see? So I don't want to just throw like, I just do like, oh, the integral of x, 1/2 x squared plus c. I want a definite integral. Okay. Let me see. Let me open the problems book. And I'm going to write FTC. Oh, did it freeze? Uh-oh. Did I freeze the program? Oh, as long as the stream is still going. Yeah, I'm using the AP Calc problems book to draw questions out of. I mean, I could just make them up on the fly, but I think it works out better when oh, here we go. All right. So let me add a page here. Okay. So let's think about, oh, this is not even the one I wanted to see. Where's the one that, all right, yeah, this will work. So I could look at like a few of these. So something like this. I'll start with something like, I mean, I don't know how basic this is. Something like 0 to 1. And then you've got x squared plus square root x. So with the definite integral, just so we're clear on what it means, like if I have some function f of x, and I have this, just so we're clear on the meaning, the integral from a to b of f of x dx, this means, like visually, it means the area between the curve and the x-axis. And the limits of integration tell you where to start and stop. Okay, so this is the meaning of that definite integral. But now, the way we evaluate it is using the fundamental theorem of calculus. And there's two fundamental theorems for calculus 1 and 2. But we usually call this the fundamental theorem of calculus part 1, and it's the most popular one next to the other. And the way we define this is that we say capital F of x is the antiderivative. This is good because it's making me sharp for what I have to be doing in about a month or so. So capital F of x is the antiderivative of lowercase f of x. So when we want to do this, it depends on how skilled you are at integrals. Like, is your antiderivative game strong? Because then you could just rewrite this first, like this, and then you're going to do the power rule. So you have x to the third divided by 3. But when I divide by 3, that's the same thing as 1/3. Plus, and then I'm adding 1 to this. All right, and when I add 1/2 plus 1 in my head, I just do numerator plus denominator over denominator. That's my shortcut in my head. And then I have 3/2 here, and then I write the reciprocal of the power in front. Because when I divide by 3/2, just know, like, if I do x to the 3/2 divided by 3/2, we do keep change flip, and it becomes 2/3. And then I write my bracket with my 0 and 1, because this means I have to plug in 1, 0, and subtract. Now, plugging in 1 and 0 is nice, because 1 to any power is 1. So that brings us here. Minus, and then when we plug in 0, it's just going to give us 0 for each of those. So this is pretty nice, that all we have to do now, 1 to any power is 1. So this is just 1/3 plus 2/3. And that's just going to equal 3/3, which is equal to 1. So somehow that area works out to 1. If I said 5 plus 5 is 12 somewhere, somebody please stop me. I don't want to put mistakes out there. But let me just see. I'll do a... oh, if you have a calculator. So this is good use of a calculator. So how do you check your answer to these? Is something essential. Let's see. All right. Let me just see. You know what? I'll freeze this for a second. Display capture. There we go. All right, I'll freeze this just to like reconfigure it. All right. So we'll check our answer. We press math 9. We went from 0 to 1. And it was x squared plus square root of x. Okay, and then dx. All right, the calculator sometimes freaks out, but this is basically them saying 1. All right, so I feel good about our answer there. All right, so definitely 1. So I gotta get a little bit more skilled here at the, transition here. Because I have 2 monitors now, but it's, a little bit tricky to, sometimes even with 2. If I had a 3rd monitor, that would be so cool. But I need to pass like 100,000 subscribers, and I will upgrade my workstation. It was fun over the summer. I got like 2 key lights from Elgato. I got a green screen behind me. Yeah, if you all want to see the behind the scenes, you can see this real quick. See, like, that's not really my background. So let me just fix that. I just don't want to pull out my shoulder in the process. All right, so yeah, as the channel grows and I have more funds coming in, I'm just going to keep throwing it back into the channel. It's fun too, having this set up. Yeah, no problem. All right, so I'm using whoops, I don't know what I just pressed. All right, I'm using a Wacom tablet and a pen. Yeah, that's how I'm doing these. That's my equipment. Yeah, and this is a Yeti Pro mic. It's just giving me this awesome sounding audio. And then I have I think it's like a C920 Logitech Pro webcam. I also have one of these, but this is a Canon M50. And what I didn't know is that when you buy one of these, the newer Canon M50s, like the Mark II, allows you to connect to a cam link so that you could record in like the highest quality. If I were to connect this by USB to my computer, it's going to lose a little bit of video quality. So my Pro webcam that I bought a year ago actually gets better video than this, even though if I use this to record video just for fun, it's sharper video than I have now. So the tech side of things is like, it's so cool getting into YouTube because there's so much to learn. Even if I pull up I don't know if people care about like the behind the scenes of YouTube, but I could pull up real quick before I sign out. One of the main programs that I use to make my videos is Premiere Pro. So that program, just wow, it could do so much. And that one I pay a monthly fee for. But that program, what's special about it is I've been using it now for like probably 2 years. And I still feel like I'm like such a noob. Like professional video makers will use that program. And it's amazing the stuff that you could do there. Like you could make the kind of videos where there's like 2 of me like talking to each other. Although with the green screen, there might be a way of just doing that, by itself. Let me just see if I get out of this. Oh, there it goes. Yeah, I guess because I'm running a lot of stuff, my computer's going a little bit slower, but my computer has like a decent amount of memory, so it should be able to handle this. Let's see. All right, this is the OBS. Sorry, I'm just thinking out loud. Here it is. So like, if I just pull up a new sample, I'll just call this. I don't know. I just spelled it wrong too. I missed the M. But yeah, a program like this. Let me see. Is my computer getting too hot? No, it's holding up. All right. Now I'll click back on my screen. But yeah, this is the program I use to make videos and like edit and stuff. But it's so dense. I mean, it's got your basic like cutting and like grouping sections of the video together, but the amount of audio effects and video effects there are, and ways of like slowing down certain parts, putting moving objects across the screen, like it can really do so much. It really is like a lot of fun to mess around with. So that's that one. I get the good notes back up. Trig derivatives took you a while to memorize. Yeah, it is tough. It is tough. Oh, we gotta know. Do you know any area between two curves with trig but non-calculator for calc A, B, B, C? And because I evaluated it wrong. Yeah, with the trig, well, so at Marin Elise, I would say it's good if the only thing you're struggling with is like the non-calculus. Then that means like your calculus is strong. So let's see. For area between, let me look up something. That'll be the last. Let me see what. Yeah, I'll say that's the kind of like one of the last topics I'll do. Let me just write area between. Area between a graph. All right, moment of truth. Let's see. Oh, that word shows up a lot. All right. I should just look for area between two curves. So sorry you're all going to hear me clicking here for a trig function. So let me just make sure I'm answering the question properly. The integral of the top function minus the integral of the bottom function. Oh, okay. Do you know any area between two curves with trig, but non-calculator? I mean, those they could do. All right, if it's just evaluating that you're getting wrong, if I think of like something like, I'll just make one up because I'm going to have trouble finding one. Like I said, for future topics, I would say send me your questions ahead of time. And my email for this channel is vinteachesmath@gmail.com. All right, because if I get specific questions and I can work them out ahead of time, it's just going to make it flow smoother because I'm going to have to hopefully come up with something good on the spot. So I'll do these in two different colors. I'll do cosine x like this, and then let's say sine x. So I don't know, something. Let me just make sure it's accurate. I'll switch to black. So this would be at pi over 2. All right, so we know sine of x is heading to 1, like this. So let's say our goal is to find this area, because if the only thing we're struggling with is evaluating, then I could give tips on evaluating. I mean, I stream at 8:30, so I normally was just planning on doing an hour and going from 8:30 to 9:30, but I started a little bit earlier so I could go a little bit over because the calc questions take a while. All right, so 8:30 is like the official start time, but I honestly only do it so late because I have 2 kids and I have to wait for them to go to sleep, because if they're in the background, like in the living room, they're gonna be making tons of noise. So I just hope they stay asleep. So yeah, full-time dad during the day and then YouTuber at night. So here, cosine x is the top function, sine x is the bottom function. And here, not drawn to scale, but this intersection point, they intersect at 45 degrees or pi over 2 radians and a height of root 2 over 2. Okay, so that tells us like where the region is going to start and stop. So yes, you're correct to say the top function cosine x minus the bottom function sine x. And then you tack on dx. And in this case, we're going from 0 to pi over 4. So for this one, the antiderivative of cosine is sine x. And now this we have to be careful. The derivative of cosine is minus sine. So the antiderivative of minus sine x is plus cosine x. And now we're going from 0 to pi over 4. At the end of this, I'm going to give tips for evaluating this. But now I just plug in. We have sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. And now here, this is just root 2 over 2 plus root 2 over 2 minus 0 plus 1. Because cosine of 0 is 1. That's like a sneaky thing to know. And this would give you, if you combine those two, 2 square root of 2 over 2 minus 1. And now this cancels. So this is just going to be square root of 2 minus 1. All right, and then in a moment I'll give some tips on how to remember the trig values. Because if you're, oh wait, I'm sorry, I'm blocking everything, and so is my microphone. So, or I could just scroll down like this. You know what, why am I leaning? Sorry, that's like a little bit silly here. Let me just go video capture. I'm gonna move myself over a little bit. All right, so I'm flying off the screen. All right, so that's if you're dealing with, what's it called? You know, something like this. And if I had to check my answer, so let me go ahead and freeze this for a second. So my display, I'm going to switch to the, oh, I can just kind of go back and forth freely. All right, come back. Is that what we just found was the integral. So math 9, and we went from 0 to pi over 4. One trap here is we're in degrees. That will ruin our answer. So I'm going to switch to radians. And then here it was sine x. Oh, sorry, it was cosine x minus sine x, I believe. Let me just see. Yeah, it's cosine minus sine. But I'm going to show you another trick too in a moment. So here, what we have, cosine x minus sine x. And then it was dx. And we get this. And we said it was square root of 2 minus 1. Moment of truth. Yay, it worked. All right. So for something like this, what you want to know is, for one, a nice little trick. This is cheating. If you have a calculator, sometimes I tell my students, like, you know what, if you can't figure out which function is the top and which function is the bottom, just tack on absolute value of x. Because that way, if you mess up the order, let's say you did sine x minus cosine x, the absolute value is going to, like, anytime the top and bottom functions switch, the absolute value will fix that. And it's only going to treat it as if everything's positive. So something like this, you see we get the same answer. So absolute value fixes stuff. But once again, if your main question is why, because I want to make sure I'm actually answering your question, but I usually evaluate wrong. That is just a trig issue, and it's a common issue because, like I said, I've been teaching Calc A, B, and BC for, when did I start? I started in spring of 2015. Okay, I took over in February. So yeah, I basically spring, not even spring. I started in February 2015. So I led one group in 2015, and then 2016, 17, 20, I missed 2020. That was the only year from this date on that I didn't teach AP Calculus, which is 1 year. That's because my first kid was born that year. So I had to miss a lot of school. All my seniors here now, that would have been your freshman year. Wait, would it have been your, yeah, it would have been your freshman year that I didn't teach calculus. So, you know, I have a lot of experience working with AP Calc students that's a common thing this part of the year, not to know how to do this without a calculator. So don't feel bad. And one thing you have to know right away is, for something like, I always think of the equilateral triangle. Let me make this a bit bigger. Okay, so equilateral triangle is 60, 60, 60. But I could put a pi over 3 here. So it's pi over 3 or 60 degrees. And then if I put a 2, 2, and let's say I drop this down. This is a right angle. Also pi over 2 radians, if we want to write it in radians. And then over here is 30 degrees up top, which is the same thing as pi over 6. So now, because this is a perpendicular bisector, this would be 1, this would be 1. And then if I do Pythagorean theorem, this is root 3. So stuff like cosine of pi over 3, I just think, all right, adjacent is 1 over the hypotenuse 2. Because, yeah, you don't get a calculator for Calc AB or BC for half of the test. So this is stuff, honestly, even to this day, when I think of these angles, 30 and 60, I'm thinking of this triangle here that I'm highlighting in red. All right, so that's what I see in my head. When I'm dealing with 45 degrees, then I'm thinking of an isosceles right triangle, where these sides are the same. So let's say they're just like 1 and 1. Then this would be square root 2. And this would be 45 degrees. Or in radians, we could say pi over 4. So something like cosine of pi over 4, adjacent is 1 over root 2. But that's the same thing as square root 2 over 2 if you rationalize, if you do times root 2 over root 2 like this. All right, so that's just something good to know. Same thing, sine pi over 4 is root 2 over 2. Tangent of pi over 4, you could say is 1 over 1, which is equal to 1. It's just opposite over adjacent. All right, so as long as you have mastered SOHCAHTOA, all right, if your SOHCAHTOA game is strong, then you'll be okay for this. All right, so I hope that helps a little bit. These triangles make 30, 45, and 60 possible. Otherwise, if you're dealing with like 0 degrees, 90, 180, 270, if it's multiples of 90, like also in radians, like 0, pi over 2, pi, 3 pi over 2, and 2 pi, and so on, then you need the unit circle. All right, but that's the key to staying accurate with those, is you have to know your trig values. All right, like that's, and once again, that's an issue that a lot of my students run into. Cool. All right, let's see what time we got here. So 9:33. So if there are, the triangle helps a lot. I'm glad. And like I said, the unit circle is the other part. All right. I would check out, the unit circle specifically, and this will be the last thing I talk about because I feel bad, I don't want to leave you hanging, is for the unit circle, these 4 values, like these 4 points, 0, 1, 1, 0. Why is this coming out so sloppy? And then we have 0, negative 1. And then we've got negative 1, comma 0. And it's this idea that on the unit circle, so this is just for the unit circle. If you're not on the unit circle, then you got to use something a little bit different. But xy is the same thing as cosine theta, sine theta, where, this is xy, and you're going like this. See, this is x, this is y, this is theta. Make that a little smaller. So this would be theta. And it's the unit circle, so the radius is 1. So that's why, like, cosine of theta is adjacent to theta, x over 1, which equals x. This shows you why this maps, but when I do things like cosine of pi, in my head, I see the angle first. I'm like, all right, pi. That tells me to spin pi radians, so that puts me here at negative 1, 0. So like that's what I'm thinking in my head. And then I say, all right, cosine is x. So negative 1. And I'm like, negative 1. And that's the answer. All right, like that's the thought process. So if I said, what's sine of 2 pi? I think, all right, angle 2 pi. Spin 2 pi. I'm at the point 1, 0. Sine theta equals y. The y coordinate is 0, 0. So this is equal to 0. Like that's like how I'm thinking about these, that I'm able to just do it fast. I don't even really, I process it, but I process it so fast now, I'm just like spinning in my head and I'm landing at one of these 4 points on the unit circle. All right, that skill takes a second to develop. What days do I stream? I'm sticking to Wednesdays at 8:30 p.m. Eastern time. When the AP test gets closer, I'm going to come up with a special schedule to like kind of overload. I'm going to definitely do more than one day a week. I also added in chess live streams on Saturday, but that's kind of like a different direction. But I'm going to stick to Wednesdays at 8:30 because I've had a decent turnout. I mean, on a day off for a lot of schools, Yom Kippur, 93 people popped up. It says so far, 4 concurrent viewers or a little more. So it's getting a decent amount of traffic considering it's so new. But yeah, and if Maren and Elise, if you could help me spread the word too, you can tell your classmates about the live stream for calculus. Right now, it's looking like a lot of calculus people. I think I had 1 geometry question so far. But yeah, I'm happy to take questions live. What I will say is the email, so vinteachesmath@gmail.com, that if you have specific questions you want me to answer ahead of time, and you could email them now, because I have to get this is week 4, so I'm still, if you look at the week 1 replay, this is definitely way neater than week 1, but each week I'm trying to come up with something new to make this like a smoother experience for the people that are stopping by. So, but yeah, Wednesdays at 8:30. So just make sure I have that formally. So our schedule is Wednesdays. So I always say Wednesday in my head. All right, Wednesday, 8:30 p.m. and Eastern time. Okay, yeah, that's the plan. Oh, awesome. I appreciate you. If you could even recruit one person, I appreciate that so much. But if you can't get, it's like, no pressure. It's just the more people, the better. This is exciting, like seeing the numbers going up here. So thank you. Thanks for your question too, because it's, it's fun keeping me sharp, making sure I'm ready to answer questions from units 1 through 10. All right. So, all right. Well, for one, just thank you to everyone who stopped by. And if you can make it next week, great. Otherwise, happy studying, happy practicing.